sometimes you will be given two functions, f and g, and you might be asked to determine where these functions are equal to each other. So maybe you're at a company and they've got a revenue function and they've got a cost function, and they want to know that break-even point. Where does the revenue equal to the cost function? But those functions you can't just factor it, get the exact answer. So you can use Newton's method to figure out that approximate solution. Okay, so where is that going to be true? That's going to be true when f of x is equal to g of x. Now, we need to find x where this happens to be the case. It doesn't necessarily the case that every x value works here. So define a new function whose root is the desired x. So what do I mean by that? So right now I've got f of x equals g of x. Well, what I'm going to do is I'm going to move the g of x over by subtracting it from both sides. And when I do that, I get a function right here, f minus g, which is equal to 0. Okay? Now I can apply Newton's method to this new function created here to find the 0. And if I find the 0, then that means I know where f and g are equal to each other. So basically all you've got to do if you've got two functions f and g and you're trying to figure out where they're equal to each other, subtract the two functions and apply Newton's method to this new function that you've created. Okay? So I've got a problem here. I want to use two iterations of Newton's method with the given initial conditions, x naught here and x naught there. So I've got, I guess, two different roots going on here. I want to approximate whenever x squared and sine of x are equal to each other. Each answer for the two iterations for both of these roots or both of those starting values, I want accurate to 4 decimal places. So to kind of get an idea of what's going on here, I'm going to graph this real quick. So I'm going to graph x squared, and then I'm going to graph sine x. And so you can see right there that we've got two solutions. Looks like at 0, and then also around point, I don't know, 7 something or 8 something. Okay, so 0.8788, something like that. Okay. So when I run through my calculations, first thing I'm going to do is I'm going to take my two functions, x squared and sine x, and I'm going to set them equal to each other. I need to define a new function where the root of the equation or the equation will be the desired x's that I want. So all I got to do is subtract f minus g. And so now I've got my function. I need to calculate the derivative of this function if I'm going to use Newton's method. Derivative of x squared is 2x. Derivative of negative sine x is negative cosine x. So I have my derivative function. I have my regular function. Now my formula to get the next x value, I take the old one minus h of the old one divided by h prime of the old one. Okay, so let's do that for this first x naught. So if I plug in to my formula, I plug in the h here, I plug in the h prime here for the 0.2, run through that math, I get negative 0.07353. And then for x2, I take this value and I plug it in everywhere I see that in the formula. Okay, that's the bottom derivative, and then the top function plugged in that x value from x1. That gets me a new value here. Now my answer needs to be rounded to 4 decimal digits. So I'm going to write 4 decimals here, 4 decimals here, and 4 decimals there. 5 or more, raise a score. 4 or less, let it rest. So I look here and I see, okay, that has a 6. So I'm going to raise the score up to a 1 here. And then this one here, that's a 3. So I'm going to let it rest with the 5 there. Okay, and even though this is 0.2, I'm going to add on 3 zeros there just so I can make sure I got 4 zeros. So you might be careful when you're doing your homework that you write out the zeros. If it says to go to 4 decimal places, it's not going to hurt anything to write those zeros. Okay, now for the second one, I'm starting at 0.7. So I'm going to plug this into my equation here, 0.7. And if I plug that into the equation, I get x1 equals 0.7. And then minus this 0.7 squared minus sine 0.7 divided by 2 times 0.7 minus cosine 0.7. When I type that on my calculator, I get 0.9428. If I take that and plug into my h and then the h prime, plug that x1 in everywhere, I'm going to get an output right here. So really it's just a bunch of plugging and chugging, and you're just finding each value. Okay. Hopefully that gives you a better idea of what to do if you're given two functions and trying to figure out, what is the solution, what x values do these functions need to have in order for them to be equal to each other.